pleasant welcome to Sporty's free webinar series and today's program on the GFC 500 Autopilot presented by Garmin Aviation. My name's Eric from Sporty's, your facilitator, and pleased to have with us Matt, Gabe, and Paul representing Garmin Aviation Training. Matt will be our lead presenter, and Paul and Gabe will be assisting with any questions in the background as well. Before we get too much further, thanks to Sporty's, of course, for hosting the webinar series, and a big thank you to Garmin Aviation for participating today on a great topic, all the ins and outs of the GFC 500 Autopilot. And I can say as a pilot, as one who actually actively flies the GFC 500, I can't say enough about its capability. Simple to use, extremely reliable, accurate, affordable, and just chock full of features. An absolute pleasure and delight to fly. With that, I want to remind everyone that today's presentation is recorded. So if you do have to step away, or if you happen to miss a point or an element of the presentation, not to worry, you can come back to the Sporty's webinar archives or also on the Sporty's YouTube channel, and you'll be able to watch the recording over and over as much as you'd like. I'd also encourage and invite you to submit any questions that you may have during the presentation through the GoToWebinar software, and our team, of course, will be there to help respond to those. With that, my pleasure to welcome Matt Clark, Garmin Aviation, who's going to lead us through the presentation. Matt, welcome. Thank you for being here with us.
Eric, thanks for having us. It's my pleasure to be back presenting with you guys again. So as Eric said, my name is Matt Clark. I am an aviation pilot trainer here for Garmin. Outside of Garmin, I am a commercial single multi-engine rated pilot and an active CFII. So when I'm not teaching the avionics side of things, I'm out teaching everyone how to fly the aircraft. So I'm fortunate enough to get to handle both ends of the spectrum there. So we've got a lot of great stuff in store for us today. As he said, we are talking about the GFC 500 Autopilot, or the AFCS, the Automatic Flight Control System. And really going to do a pretty good deep dive as to what this system is capable of doing. So of course, we're going to start off with our standard disclaimer here. Today, we're going to try to provide some of the best practices, best use for the autopilot. Now that being said, we are not a replacement for any service bulletins, pilot's guides, aircraft flight manual supplements, anything like that. I do highly recommend obviously following the guidance that is in there, especially when it comes to your aircraft flight manual supplement. You'll hear me reference that several times today as we go through this. So, but just keep all that in mind as we're going through. We are going to run through some best practices for the system itself. So with that said, we're going to start off today with talking about these different systems, components, and some potential layouts that's going to make up the GFC 500. We'll then dive into our AFCS statuses and annunciations. Where can we see what's active, what's armed, where do we see all this information at? We'll then do a good discussion over our mode selection, both our lateral and vertical mode selections, how we're going to be able to use some of that in flight, what those annunciations look like as well. We'll talk about our electronic stability and protection, or ESP. And we'll cover a few abnormal operations. I won't be able to cover every single abnormal operation out there, but we're going to cover some of the high-level abnormal ops that you could see. And at the very end, we are going to end the scenario today with a flight scenario, starting us from takeoff, en route climb, en route flight descent, VNAV approach, missed approach, and how we're going to let the autopilot handle that for us. Now, as Eric said, if you do have questions, I do have a couple of colleagues with me today. Feel free to use the questions box within the GoToWebinar platform, and we'd be more than glad to answer any questions you have. If you do have a question that either does not get answered today, or you have a question as you're out flying, then please email us here at aviationtraining.webinar@garmin.com. That's going to come straight to the training team, and as I've said, we'll be more than glad to answer any questions that you have. All right, with that said, let's go ahead and jump in and start looking at the system components and layout. So first off, when the GFC was first certified, compared to some other autopilots, this is an attitude-based autopilot. So one key instrument here, potential instrument, is the G5 flight instrument. Obviously filling in that standard 3 1/8 inch cutout, big bright LCD display, built-in GPS, and this is our ADAHAR source, our air data, attitude, and heading reference system. This is providing that attitude source for the GFC 500. Now we know last year, the GI 275 multifunction instrument came out, took a little bit, but we got that added on as an approved attitude source for the GFC 500. Similar to the G5, still fits that standard 3 1/8 inch cutout. This time it's back mounted in the panel. Still a big bright LCD display, built-in GPS. This is a touchscreen unit, whereas the G5 is not, but it's still providing the ADAHARs from the attitude information for us. Now there are multiple variants of the GI 275. The installation manual does call out a specific variant, so get with your dealer, make sure that you have the right unit or that you're purchasing the right unit before you get it installed. Another option for us is the G3X Touch, our primary flight display. This can act as that ADAHAR source for us. Obviously, we need to have it as our primary flight display. You can have this installed standalone if it's a VFR installation. If you're running an IFR install, you're going to have a backup standby instrument of some sort. And you can interface these with their external navigators like a GNS WAS, a GTN, or our GPS series of navigators. Any of those are going to work as our source for this autopilot. Another standard piece of equipment for us is the GMC 507. This is our mode controller. This is what we're using to control the autopilot with. Separated out into 3 sections. We'll go into a little bit deeper dive here in just a little bit, but the left-hand side is your lateral mode selections. The center section is your autopilot engagement section, and the right-hand side, your vertical mode selections. As I said, we are going to come back and do a little bit deeper discussion, so we are going to look back at this in just a little bit. Another obviously required piece of equipment for the GFC 500 is the GSA 28 Smart Servo. This has built-in electronic torque and speed sensing. It is a brushless DC motor design, and there's no mechanical slip clutch. Ultimately, what does that mean for us as the owner-operator of the aircraft? Well, it means you're going to have overall improved performance. You're going to have reduced maintenance and reduced maintenance costs as we talk about the longevity of the unit, and very smooth control movements, whether we're trying to hand fly or when I fly behind this autopilot, if I'm hand flying, I can't even feel that there's a servo there. When it is engaged, it is very smooth, very controlled. Now, some of the layout, you are going to see a little bit of different layout based on the aircraft. The example here, I'm using a Beechcraft, but you will see some different layouts depending on the aircraft, especially with the pitch, roll servos of where they're mounted in the aircraft. But here we have a very basic setup, either a G5 or a GI 275 as our attitude source. The GMC 507, we can see there's a roll servo, pitch servo. That's the very, very basic of this. We can add a GMU 11, that's going to be our magnetometer, typically either in the wingtip or in the tail, providing magnetic heading information for us. The option of the pitch trim servo, which is going to add automatic pitch trim, as well as adding in a manual electric trim to the aircraft. Your aircraft may already have that, in which case we're just replacing the servo, or it could be a new addition into the airframe. Either way, it's a very nice feature to have. And depending on the aircraft, you could have the option of a yaw damper. It's going to help minimize some yaw oscillations, helps maintain coordinated flight. I would very much recommend talking to your dealer. Is a yaw damper an option for the aircraft? Is it worth adding in or not? So great conversation to have with your dealer. For the GAD29 Bravo, this is an interface box. If you're running a G5 or a G3X Touch system, the GAD29 is that interface between are different VHF and GPS units such as a GNS WAS, a GTN, or a GPS series of navigator. If you're running a GI-275, that interface is already built into the GI-275 itself. We don't need that separate interface box. So here, all we need to do is just have the single unit. And of course, we do have some integration with selected Garmin primary flight displays for syncing of bugs, for autopilot annunciations, flight directors. There is a little bit of variation depending on what unit we have installed of what's going to talk back and forth. Once again, I'd recommend talking with your dealer as to what's going to communicate and what equipment's going to be the best for your aircraft. All right, so that was a very quick high-level overview of the different system components that were in there. Now we're going to look at the AFCS Annunciations themselves. Where are they? What do they mean? And how can we interpret what the autopilot's trying to do? So first off, we're looking at the G5 and the GI-275, and I've got these units side by side here. First off, right in the very center, we see the magenta bars. Those are your flight director command bars. There's my pointer. We can see both on the G5, GI-275, they're identical to one another. If you're running another flight display and the flight director is displayed on there as well, it should look very similar to what you're seeing here. Your mode annunciations for these two instruments do vary just a little bit. On the left-hand unit, that's the GI-275. Our mode annunciations are at the bottom of the display, whereas on the right-hand unit, the G5, they're at the top of the display. That is really the only difference between the two. Beyond that, the actual mode annunciations, the terminology, everything there is still going to stay the same. On the left-hand side of either unit is your lateral mode annunciation. The center section is the autopilot engagement section. Right-hand side on both units are your vertical mode annunciations. So even though the annunciations are in different spots, they're still telling us the exact same thing. Now for those running one of our other flight displays, such as a G500 TXi or a G3X Touch, those annunciations are going to appear at the top of the display. Notice your G500 and your TXi are the center and left-hand units. Both of those units at the very top are showing the same annunciations in the same spot. G3X Touch, however, is the only unit that rearranges the order of the annunciations. Here we can see our autopilot engagement section is on the left. Our lateral mode selection is in the center, and the right-hand side is our vertical mode annunciation. So there is a little bit of difference there. But beyond that, the actual annunciations themselves will stay the same. Now here on the right-hand side of the screen here, you can see here's all the different annunciations that a Garmin unit is going to show, and they're all going to show the same thing. We also follow the same color code or the same logic. Green is your active mode. That is what the autopilot is currently doing. If you ever ask yourself while you're flying, well, what is my autopilot doing? Well, we need to look at the annunciations and we need to see what's green. The green is what the system is doing right now. White is an armed mode. It means we're waiting to do something. Could be waiting to capture an altitude. We're waiting to capture a final approach course. White is armed. Now yellow, as you're running your autopilot, yellow is going to be a pretty common color you're going to see. It means you've either disengaged the autopilot or there is a mode drop. I've got a better slide coming up here in just a little bit discussing that. But if you manually disconnect the autopilot, either through the autopilot disconnect on your yoke or stick, or you hit the AP button on the GMC 507, either one, that's a manual disconnect, you're going to see a yellow flashing AP. Now the red is an abnormal disconnect. So if something else in the system causes the autopilot to disconnect, that's when you're going to see red. I'm going to discuss that here just a little bit when we get into the abnormal section. Now, of course, you're going to hear me say this, especially as we get to our flight scenario, always verify what your active and your armed modes are. we'd never really want to asking ourselves, what is the autopilot doing? We want to know. So anytime we make a change that's going to affect the autopilot, we need to go back and verify all of our active and armed modes, make sure that the autopilot is doing what it's supposed to, as well as it's doing what we're expecting it to do. If it's not, then we either need to drop down a level, and such as going into heading mode and altitude hold, or absolute worst case scenario, disconnect the autopilot and hand fly. All right, so we've seen where we see the annunciations. Now we're going to take a little bit more time and let's talk about all the different modes that are available with the GFC 500. So first, I'm going to start off in the center section here, our autopilot engagement section. So first off, the first button is the AP button. Pressing that is going to automatically turn the autopilot on. It's also going to automatically turn on our flight director, and if we have one installed, the yaw damper. Those automatically engage. Now the flight director and the yaw damper, both options down at the bottom, can be turned on independently of one another and independently of the servos engaged. So if I'm wanting to hand fly an approach or hand fly the aircraft, but I still want that flight director reference, I'm only going to use the flight director option. I'm just going to keep the autopilot itself off, the servos disengaged. Now the other button on here is our level button. Pressing the level button will engage and turn on the autopilot if it's not already on. It's going to command the wings to level and command the aircraft to a 0 vertical speed. We're coming back to level flight. This is a great option if we start getting spatial disorientation, we encounter inadvertent IMC, anything like that, where level flight is going to be key. This is a great option for us. Now, another option, the only display that won't show this is our G500, the GDU 620. When the flight director's on, it's a filled-in command bar. But all of our other displays will show a hollowed out flight director. In this case, if the flight director is turned on, but the servos are not engaged, the autopilot is off, means we are still hand flying the aircraft. We're gonna see that as part of our annunciation, either at the top on the G5, one of our flight displays, or on our GI-275, but this is another cross-check for us. Hollow magenta command bars means the servos are not engaged. Whereas if I turn the autopilot on, I see the light appear on the GMC 507. Our command bars fill in. Now the servos are engaged and they are flying the aircraft. Another option for us here, most aircraft are going to have a toga button or a takeoff go around button. This is a combined lateral and vertical mode. If you're on the ground and you select toga, this is automatically going to turn the flight director on. It's going to pitch the flight director to a takeoff pitch attitude, and this attitude will change and vary based on the airframe. Reference back to your flight manual supplement for that specific. But you're going to see a lateral takeoff mode and a vertical takeoff mode. We're keeping our wings level, setting a takeoff pitch attitude. If we're in the air and we select the toga option, this does a go around lateral mode and a go around vertical mode. Very similar to what we're seeing on takeoff. It's keeping the wings level. It's setting the aircraft to a go around pitch attitude. The advantage here, if we are still coupled to the autopilot, selecting toga does work the coupled go around capability. So we select toga, we pitch, we power up, we clean up flaps and gear, and now we can start into our missed approach procedure. Our lateral mode selection is on the left-hand side of the GMC 507. The first mode, now while not specifically a mode that we can select necessarily, is roll mode. This is a default mode. If we're to simply turn the autopilot on, we hadn't selected toga, we hadn't turned a flight director on, if we simply select the AP option, roll is the first mode. Essentially, it's keeping our wings level. It's a very, very basic mode. Next up, we have the heading and track knob. This is going to select and rotate our heading bug or track bug as appropriate. got a better screenshot describing the two differences there in just a little bit. Down at the bottom, we do have a heading mode. This is going to follow our selected heading bug on our G5 and continue following that as we go. Track mode is very similar. This is instead of taking and following a specific heading, track is going to follow a specific GPS ground track. If you're running a magnetometer, more than likely you're going to use heading mode. If you don't have a magnetometer installed, you're going to use track mode. But for those that do have the magnetometer, either option is still available to you. Nav is going to be one we're going to use, probably the most common. This is going to track and follow whatever our current nav selection is. So for example, if we're following GPS course guidance, then when we select nav, we're going to see a GPS annunciation. Same holds true for tracking a VOR or a localizer. Now the last button on that side is approach mode. We're going to use approach mode if we're going to track and couple to an approach that has vertical guidance. So it says an LPV, an ILS, or an LP plus V, or an LNAV plus V. The plus Vs, we will still use an approach, well, still arm approach mode. So if appropriate, if we're outside or more than half scale CDI deflection, when we select approach mode, it's going to arm our lateral mode. If we're already tracking that mode, however, then there's no reason to arm it. It's simply going to keep our active lateral mode. It will also arm our vertical mode, such as GP for glide path, that's for GPS or RNAV based approaches, or GS for glide slope, those ILS based approaches. Now here, we are talking about difference between heading mode and track mode. Heading mode, if we look on our HSI or at the very top of our G5s, any heading bug for us there is going to be cyan. We see that blue coloration, we're following a heading bug. Versus if we're following track, the moment I select the track option, our heading bug is going to change to a magenta icon there. That means we are following track instead of heading. That is following a selected GPS track. It doesn't necessarily care what the wind is doing. It's just going to follow that straight line. All right, on the right-hand side, we're going to discuss our vertical mode selections. Now, we mentioned on the lateral side, if we were to turn the autopilot on without having anything else selected, roll was the default mode. In this case here, our pitch mode is our default mode. So if nothing else is selected, I turn the autopilot on, it's going to pretty much capture our current aircraft pitch. That's all it's going to do. The up and down wheel, we can use that to adjust either our indicated airspeed, our vertical speed, or that pitch reference. So that up and down wheel is an icon or an option there we're going to use on just about every flight. We do have our altitude select knob. This is going to allow us to adjust our altitude. We'll see that on our G5s, GI275s, or flight displays as we change our altitude selector. And pressing that knob in syncs that selector to our current altitude. The altitude button itself, all that is going to do is capture our current indicated altitude. So in this case, I selected altitude. It's shown here at 7,000. I can then use the up and down wheel and I can fine tune the altitude plus or minus 200 feet without having to use the altitude selector and without having to change to either vertical speed or indicated airspeed. So if you're going beyond 200 feet, then we've got to set our selector, select a vertical mode, and adjust from there. Other modes on there, we have our indicated airspeed and vertical speed. Selecting either option there is going to capture either our current indicated airspeed or our current vertical speed as appropriate. So if we're starting to descent, I like to use vertical speed. If I'm climbing, I like to use indicated airspeed. That's my personal preference. My recommendation, you can use either mode, either direction, but that's my preference. So if we started a descent or a climb, we're going to start with our altitude selector, pre-select the altitude first. We'll then either select indicated airspeed or vertical speed as appropriate, and then we can use the up and down wheel to fine tune and set the speed or set the desired rate. The last button on there is our VNAV button. Now this is going to allow for pre-programmed descents. Now I'm not going to go too terribly in-depth into vertical navigation. I would recommend we do have a couple videos and recorded webinars out where we go into a lot more detail on vertical nav, but we'll talk a little bit about that towards the end of the presentation in our scenario. But in order for vertical navigation to work, in order for the autopilot to couple to that VNAV path, we need either GTN with software 6.5 or higher, or GTN XI. Now, a couple cautions we have here. So selecting an already active mode. So if we're in nav mode and following GPS guidance, and I select the nav option on the controller a second time, this will cause the GFC 500 to revert back to a roll mode. Same applies to the vertical mode. If we're in a vertical speed descent or an indicated airspeed climb, select that option a second time, reverts us to pitch mode. So that's how we can get back to that roll or pitch mode if need be. The other caution I have is if you are actively navigating on a nav mode, you are tracking let's say for instance, you're following GPS guidance and you manually change from GPS to VLOC, this will revert the autopilot to a roll mode. We've told the autopilot that we're following a specific lateral guidance. When we change that source automatically, the autopilot doesn't know any better, so it goes to roll. All right, now let's discuss a little bit of our ESP, our electronic stability and protection. So electronic stability and protection, in a sense, is trying to keep us within a safe, protected flight envelope. We're going to correct for bank, for pitch, and for airspeed, all three. The further we go outside of this protected envelope, the greater the force we're going to feel on the servos. They're going to turn on and they're going to try to guide us and correct us back into our safe protected envelope. Now this feature is automatically armed upon passing 500 feet AGL, will automatically disarm below 200 feet AGL. We don't want ESP trying to activate as we're coming into land or coming into a flare. Now on our roll protection, we are trying to discourage going beyond 45 degrees of bank. And on our primary flight displays, G5, GI275, TXi, G3X, etc., at the 45 degree mark, you're gonna see that double hash mark. That is our ESP limit. Inside of 45 degrees is our safe envelope. The moment we roll beyond 45 degrees of bank, those marks are gonna go to 30 degrees, and we're gonna feel the servos engage and start nudging us back into the safe envelope. The more we go beyond that 45 degree limit, the greater the force the servos are going to apply trying to correct us back in. Same thing applies to pitch. Your pitch too high, pitch too low, we're going to discourage beyond specified limits. Those limits are going to vary airframe to airframe. So this is where taking a look at the aircraft flight manual supplement is going to be key. Know where those limits are, but it's the same principle. The further we go beyond that protected envelope, the greater the servos are going to start trying to nudge us back to that safe envelope. Now, ESP can engage level mode for us. If we are outside of our protected envelope for more than 10 seconds within a 20-second time frame, we're going to get an oral alert that the autopilot is engaging, and we're going to go into level mode, and that's the annunciation you're going to see. We have a level lateral and a level vertical mode annunciation. Now this is automatically, level mode via ESP is going to automatically arm above 2,000 feet AGL, and it's going to disarm below 1,500 AGL. Now I can always manually press the level button on the controller at any time and turn level mode on, but this is strictly level mode via ESP. Now we also have our high speed and low speed protection. High-speed protection is trying to keep us from exceeding VNE, trying to exceed maximum speed limitations set by the manufacturer. Low-speed protection is going to try to prevent us from going below a specified airspeed. Now, to clarify, this is not stall protection. Now, on many aircraft, low-speed protection is below a specified stall speed, but we're not protecting against stall. So if you're doing an accelerated stall, or depending on the airframe, I know several airframes out there, their stall range can vary based on weight, based on center of gravity, based on flap settings. There's a wide range there. So we're going to try to pick a value that allows for normal flight, but that's going to try to protect in as many situations as possible. Once again, go back to your flight manual supplement and I have an understanding of what that speed is. Now for low speed protection, this is going to require either a GNS WAS or a GTN or GTN XI. And of course, low speed protection is always going to be inhibited below 200 feet AGL. Overspeed protection, this is not necessarily electronic stability and protection. This is a function of the autopilot while it's engaged, but is operating very, very similarly to our ESP, low speed and high speed protection. Overspeed, we're trying to keep the aircraft from going too fast. We're going to get a max speed alert on our display. Our vertical mode is going to change to indicated airspeed. We're going to try to keep the aircraft underneath VNE and start the aircraft climbing. Our previous mode becomes armed. Once we slow down, get the aircraft stabilized, our previous vertical mode becomes active again. Low speed, or underspeed protection, very similar. We're keeping you under an established speed, a specific airspeed. Again, take a look at your flight manual supplement for more details there. Get a min speed alert, and we're doing the opposite. This time we're decreasing the nose. We're pitching the nose down to increase airspeed. Vertical mode still goes to IAS, or indicated airspeed. Get that oral alert of airspeed. Once we've got some more airspeed going again on the aircraft, then previous mode becomes active. So we're trying to keep you in a safe envelope, or as much of a safe envelope as we possibly can. Now, we can get around ESP. So the first round, if you know you're going to be going beyond that 45 degrees of bank or that pitch or speed bank, if you press and hold the autopilot disconnect, press and hold it on the yoke, that's a temporary disconnect. Now, the moment you let go, ESP's automatic is going to kick back in. So if you're beyond 45 degrees, you let go of the AP disconnect, you're going to feel the servos engaged. But we can disable it longer. So if we're doing multiple maneuvers and we know for a fact we're going beyond that limit, and we're fully accepting that fact. On G5, if we press the knob in, so scroll over to our ESP option, press the knob again, that's going to either enable or disable based on the green light on the display. GI275, very similar, either hold the knob or swipe up from the bottom, select options, and the same option, go over to ESP, that's where we can enable or disable the feature. If you have G3X, we're actually going to touch the AFCS status box, those annunciations at the very top, and then we can go over to our ESP box, select that field, and this is where we can turn that on and off as well. All right, a couple abnormal operations. I'm not going to be able to cover everything. Once again, take a look at your flight manual supplement. It's going to have a lot more potential scenarios in there. But the first one is a yellow flash, typically a mode drop of some sort. The first one here is if we changed our CDI source. So we can see I have a yellow GPS and a green roll mode. This is a case where I was following GPS guidance and I manually changed my CDI source, my GNS or GTN to VLOC, and we see a yellow flash there. Now we're just simply maintaining wings level. To re-engage and continue following our new selected nav course, I would need to select the nav button on the GMC 507. You'll also see it manually disconnecting the autopilot, hitting the AP disconnect or on your yoke, or selecting the AP button on the GMC 507. Either one, you're going to see the AP flash, you're going to get a tone. We've disconnected the autopilot. An abnormal disconnect is that red AP. So if something happens, something caused the system to force that disconnect, we see the red AP, you're gonna get a continual oral tone until you acknowledge. Now we acknowledge it by either pressing the autopilot disconnect on our stick or yoke, or pressing the AP button on the GMC 507. Either one, we've acknowledged that there's an abnormal disconnect and we are now hand flying the aircraft. Couple other potential options here. If you see a red AFCS, that means your autopilot has failed. It's also going to tell us that the flight director is not available. So we are fully on. We have no flight director guidance. We are hand flying the aircraft. And if we see a amber AP with a red X across it, it means the autopilot's failed, but the flight director is still available. So we can still use that for some guidance. So couple quick scenarios of some abnormal ops that you may see. Of course, a couple warnings in flight: do not try to overpower the autopilot. Let's see on the pitch axis, this is going to potentially result in a large opposing or out of trim condition. We don't necessarily want to do that. So grip the controls firmly, disconnect the autopilot, retrim as appropriate, and hand fly. We also don't want to try to re-engage the autopilot or use a manual electric trim until we've determined the cause of that malfunction. So if you do get that abnormal disconnect, we want to know what's going on before trying to use the autopilot again. All right, so we've covered a lot of information. Now we're going to roll into a flight scenario today. So for our flight scenario, we're taking off. We're down in Texas, going from Sierra Foxtrot. We're going to fly direct to the THX VOR and then down to Tango Foxtrot Papa. Pretty straightforward, pretty easy route, no arrivals, no departures. We're keeping ourselves clear of some MOAs, as well as, for the most part, keeping out of some alert areas. Our alternate here is going to be Corpus Christi, just in case we need it. Equipment that we're going to use for this flight, we're saying we're using a G5 flight instrument, a GMC 507, and a GTN 650 XI. If I was using a GI 275 or G3X, as far as this scenario, I want to treat them and operate the autopilot in the exact same fashion. Nothing is going to change. So first off, we're going to start off on the ground here at our departure airport. ATC instruction says on departure, fly a runway heading, climb and maintain 3000, runway 14 cleared for takeoff. Pretty straightforward instruction for us. So first, we're going to start off. I'm going to use my heading knob on the 507, and we're going to select the appropriate heading, in this case 140. I can verify on my G5 I've got 140 set. We're going to set the altitude to 3000. So I take my altitude selector knob, I set 3000 on my display. And from here, I'm going to press TOGA, or takeoff go around. This is going to give me a takeoff lateral and a takeoff vertical. And there it is. There's takeoff lateral. We're keeping the wings level. Takeoff vertical, we've set the aircraft to a climb pitch attitude. And of course, we want to verify that everything comes up. We see the flight director. It's at the appropriate flight pitch that we're expecting. Life is good. We also want to verify, in this case, that ALTS, this is altitude target select, is armed. So ALTS means when we reach our selected altitude, in this case, 3000, that's where the autopilot is automatically going to level off at. I don't need to worry about trying to manually arm an altitude capture mode. It doesn't apply on a Garmin autopilot. Simply setting the altitude selector is going to do the job for us as long as we see ALTS. So we're going to take off. We add power. As we get off the ground, flaps up, gear up as appropriate. Upon reaching 800 feet AGL and above our minimum engagement speed, we can engage the autopilot. This is straight out of the AFMS. So when we do that, we're going to press the AP button on our GMC 507. And of course, we want to verify our autopilot once again. We're still in a takeoff mode. Our wings are level. The autopilot's on. We see our flight director is now filled in, so the servos are engaged. And I see a takeoff vertical mode, meaning we are at a climb pitch attitude. Altitude select is armed, and we're going to level out at 3000 feet. As we continue our climb, I'm going to go ahead and select heading mode. So I can select heading. I can verify that now we're following our heading bug. I can also engage indicated airspeed. So instead of, I don't necessarily like climbing at a pitch attitude if I can help it. I would much rather climb at a specified airspeed. So that's VY, or if you have a cruise climb airspeed that you'd rather climb out at. We select IAS. It's going to capture and follow our current indicated airspeed using the up and down wheel to fine tune the airspeed as appropriate. And of course, verify our mode annunciations once again. So we're following heading, the autopilot's on, we're in an indicated airspeed climb at 110 knots, altitude target select armed, leveling us out at 3,000. Next instruction from air traffic control, proceed direct THX, take a hotel x-ray, climb and maintain 7,000. Pretty straightforward option for us here. So first off, we're going to start with the direct to on our navigator. We go to our GTN, either direct to THX, or go to the flight plan, select it, direct to, off we go. So we started with our direct to, and then we're going to select nav mode on our autopilot on the GMC 507. We can verify up here, we see GPS, so now we are tracking and following that GPS track that we've set. Next, I need to set the new altitude on our via our altitude selector. So I'll use the knob, set 7,000, verifying that on our flight display. Now, if we had already leveled off at 3,000, I'll need to go back, reselect IAS, use that up and down knob, and set my climb pitch or climb airspeed again. If we had yet to reach 3,000, if we were still in our climb, then all I need to do is roll the altitude selector up to the new assigned altitude, and the aircraft will keep climbing at the specified airspeed. And of course, verify. So we're following GPS guidance. The autopilot is on, still in our indicated airspeed climb at 110 knots. Altitude target select is armed, and now leveling us out at 3,000. All right, as we level off, we're just gonna monitor our mode selections. We start at the very top, typically within 200 feet. This can vary based on our climb rate. We will see ALTS go from armed to active. So it was white before, now it's green, and it automatically arms ALT, or altitude hold. So here we're prepping, we're in that transition phase, the leveling out. And then as we reach 7,000, I'll see up here, altitude hold at 7,000 feet becomes active. Our indicated airspeed mode is going to drop off automatically. And now we can get into the cruise phase of flight. Run through any checklist as appropriate and get ourselves en route for our cross country here. Now, as we're in flight, I recommend keeping that AFCS status as part of your instrument scan. We don't want to simply ignore it. We want to continue to verify that everything is going as we expect it. This is a great option, especially in case of an abnormal disconnect, or if we accidentally hit the AP disconnect on the yoke or the autopilot controller. We want to verify all those modes and just keep in that instrument scan. All right, now as we get in, we've passed the THX VOR. We are starting our descent and coming into our destination airfield. So first instruction ATC gives us, descend and maintain 5,000. Pretty straightforward answer, pretty straight instruction from air traffic control. So whether it's a climb, whether it's a descent, we're always gonna start with the altitude select. So I'm gonna set my altitude selector down to 5,000. I can verify it on the flight display. We are at the selector is set to 5,000. I like using vertical speed in the descent, so I'm going to use vertical speed. When I press the VS button on our 507, it's going to capture our current vertical speed, which if in level flight should be 0. I'm then going to use the up and down wheel to set my desired vertical speed rate. So in this case, I'm setting 700 feet per minute. depending on the display, so I have G5 here, or if you had TXi, G3X, you'd be able to see on my vertical speed tape of a vertical speed bug. I can also see on the Annunciations, it's vertical speed, and I've set negative 700 feet per minute down. So set whatever rate you wanted to send at. And of course, ALTS is armed, and that's going to level us out at 5,000. And there we go. We verify the vertical speed's active. We verify ALTS is armed. We know where the autopilot's going to level us out at. Now, coming into the approach, I like to be as far forward as I can possibly get. So in this case, I'm looking at the weather ahead of time. I can see the destination airport, they're using the RNAV 31, or the winds are favoring runway 31. So I'm gonna go ahead and load the RNAV 31 into my navigator and have it standing by ready to go. Of course, the recommendation from the training team, we always want to pick the transition that's going to make the most sense. The GTN does default to vectors, but pick that transition, pick the initial approach fix that's going to make the most sense for what we're trying to do. So in this case, I'm picking a SICI and have that loaded in my flight plan. I load that in. I see there's a SICI. I see the approach, the RNAV 31. It is an LPV approach, so I'm expecting an approach with vertical guidance. So we're just in preparation. We're ahead of the game as we're coming into their destination airfield. The next instruction, as we get closer in, they tell us to go ahead and proceed direct as SICI. Now, there could be some more communication between us and ATC. They've told us to expect an approach. Either way, we've got it loaded in our flight plan. We're ready to go. So here, I'm going to go down to my flight plan. I can select a SICI, activate direct to on our GTN. And at this point, since we're already following GPS guidance, the aircraft is automatically going to start that turn and start proceeding to the new waypoint. I'm going to verify that our nav mode is still active. So I can still see we're in GPS guidance. I don't need to rearm, or I don't need to press nav a second time, because we're already still following GPS. So we get a little bit closer in. ATC tells us to send pilot's discretion across the SICI at or above 2,000. Now, working VNAV, we run a three-step process. Step one is to verify your altitude constraints in the flight plan. Well, I can verify in the flight plan is SICI, it's an at or above 2,000. It matches up to what the chart says. It's matching up to what ATC is telling me. So this is good for what we want. So step one is complete. Step two, we need to set our altitude selector to the lowest assigned altitude. In this case, down to 2,000. Now I'm still level here at 5,000 feet. I can roll my altitude selector down without worrying that the aircraft is going to descend away from me. So we set 2,000. Step three, arm VNAV. Now, unlike some G1000s, there is no time limit on when you can arm VNAV. I can arm it as early as I want. As soon as we reach the top of descent, VNAV becomes the active mode and we start our descent down. All we have to do is manage power. So following those three steps will result in a lot more better, or at least a better result trying to use vertical navigation. And of course, verify. We're still in altitude hold of 5,000, vertical nav's armed, altitude selector set. We're in great shape. 1 minute prior to top of descent is when we're going to see our vertical deviation indicator, the VDI, with a magenta V. And that's also, depending on the display, when we're going to see a vertical speed target appear on our VSI. Prior to that, those options are going to declutter off the display. Now, when that magenta V centers, that's when VNAV is going to become active and start taking us down that program descent. Now, and this is a great case here. Now we get a little bit closer in. We're following our VNAV descent down. ATC clears us for the RNAV 31. So I try to stay to this as best as I can. When ATC clears us for the approach, I want to arm approach mode. So I'm going to select the APR button on the GMC 507. I see we have glide path armed, and I see ALTV. That's VNAV target altitude. Still going to level me out at the altitude in the flight plan, which in this case is 2,000 feet. Now my warning, my caution here, VNAV and approach mode with a GFC 500 cannot be both armed at the same time. If you have VNAV armed and you arm approach mode, you're going to cancel out the other mode and vice versa. So I'm going to go back a slide here. What we can do is when VNAV is active, I see it in green, it's active, that's what we're currently flying, then I can go and arm approach mode. So that's good. So we can't arm both at the same time, but this is our workaround here. The other caveat, the other caution I have for you here, GTN VNAV by itself can take you to the final approach fix. However, with the GFC 500, there is no transition to approach, so VNAV will end at the waypoint preceding, one waypoint prior to the approach fix. So what does that mean for us in this case? Well, here's the RNAV 3.1. I'm going to zoom in a little bit on the profile view here. We see there's the at or above 2000 at ISICI, but there's another constraint, NEGIC at 1500. So depending on the approach, I may need to come down a little bit further to guarantee glide path or glide slope intercept. In this particular case, I don't need to do that. If I'm level at 2000, I cross the ISICI, I'm at an altitude that's going to guarantee glide path intercept. So I'll let the autopilot and VNAV descend me to 2000, I'll level out, and then from there, I can capture the approach vertical guidance that'll then take me the rest of the way in. And that's what we're going to do. So here, we've let VNAV level us out. We're here at 2000. We're prior to the final approach fix. Our approach mode's armed. I see glide path up there. Great time to verify that we're on the proper CDI source. I see a magenta needle showing, yes, we are following GPS guidance. I see a magenta diamond for our glide path. Prior to the final approach fix, this is also a great time to go ahead and set our missed approach altitude here at 2100. And we're going to follow that diamond all the way down. Where the diamond centers, glide path becomes the active mode, and now we're on approach vertical guidance, starting our descent for the approach. Now with this type of approach, this is a precision type approach, we have two options once we reach decision altitude. Either A, disengage the autopilot and land, or B, we don't have our clouds and visibility, we select toga and go around. Per the flight manual supplement, below 200 feet AGL, we have to disengage the autopilot. Really for this, my recommendation, below a decision altitude, if we're going to fly below DA, disconnect and hand fly. But for this scenario, we're going to run the case that we didn't have our cloud, we didn't have our visibility, a sudden rainstorm could have come in, something's causing us to not have what we need to land. So we need to go ahead and fly. We weren't given any special missed approach instructions, so we're going to go ahead and fly the published missed approach. So sequence of events for us. We hit our decision altitude, we're going to select toga. This is going to activate go around mode laterally, go around mode vertically, keeping the wings level, go around pitch attitude. Great time once again, verify our missed approach altitude. We're going to power up, clean up, flaps up, gear up, all of that as appropriate. After we've done all that, we need to re-engage nav mode. Re-engage in nav mode will now let us follow the rest of the missed approach procedures laid out in our flight plan. So I can see I selected nav, we're back to GPS, but I'm still at that go around pitch attitude. If we're in a prolonged climb, if it's a long climb to our missed approach altitude, I like to go ahead and revert back to indicated airspeed. And now we're looking very similar to what we did on takeoff. I'm following, in this case, GPS guidance to our missed approach. I'm in an indicated airspeed climb at 110 knots. ALTS is armed, and it'll level us out at 2,100. As we get into our missed approach, ATC starts telling us to expect the localizer 3.1. So with the in this case, we're still verifying nav is the active mode. We're following the published missed. We're going to verify that we're at our missed approach altitude, and I can see that here at 2,100. We want to verify the aircraft is in the missed approach hold. Once we're in the missed approach hold, the GTN gives us the option to load up a second approach without deleting our missed approach hold. So here I can see we're in our missed approach hold, but I've loaded the localizer 3.1 into Corpus Christi. It's loaded, same recommendation as before. Pick the transition that's going to make the most sense, but we can have it loaded, ready to go. From here, ATC is going to give us some help getting over to Corpus Christi. They give us a vector. So flight heading 160, vectors for the localizer 31. So first, I'm going to start with our heading bug. I'm going to use that heading knob, select 160 on my heading, and then I'm going to engage the heading bug. I recommend doing that first. We may have forgotten to resync a heading bug. This is going to verify that it's going to turn us in the direction we're expecting to go. But once I press heading, we're going to go back to our controller or to our AFCS Annunciations, and we're going to verify that heading is the active mode. We can see that here. Now they give us a few more vectors. We start getting in closer to our approach. ATC finally gets us that intercept to final approach course. Said fly heading 280 to intercept the localizer, maintain 2000 until established, cleared, localizer 31. So in this case, we're going to set a heading bug to, in this case, 280. So I use the bug or the heading knob to select that. We're still in heading mode, so we're still in good shape. We're going to verify that we have vectors to final active on our navigator. They vectored us to the final approach course. So that's a perfect use case for vectors to final. And when cleared, now this is a case, this is a non-precision approach, and more specifically an approach without vertical guidance. So what we're going to do is we're going to arm nav mode. So we use approach mode for approaches with vertical guidance. We use nav mode for approaches without vertical guidance. So I select nav, and I can verify on my AFCS status, localizer is armed, heading mode is still active. We're on our following that assigned heading, we're waiting for the CDI to center so we can start tracking and following the localizer. And of course, verify the CDI source. In this case, make sure we're on VLOC. I see the green needle on my G5. We're on the proper source. And we verified all of our modes. Localizer's armed, heading's active, where autopilot is still engaged, altitude hold of 2000. And of course, as we get in, we intercept the localizer, loc becomes active. Typically, when you're with less than half scale deflection on your CDI, that's when the lateral mode becomes active. And then we get ourselves established with the final approach course. We're verifying that localizer capture. And now we're going to work our altitude bugs using the altitude selector to start working our altitude step downs. So in precision type approaches, I set my altitude selector to the missed approach. For the non-precision, I want to use it to start marking down my next altitude step down as appropriate. So in this case, the next altitude step down is 1,300. So I'd start with the altitude selector, cross over the final approach fix. We can use vertical speed and start our descent down. Remember, this is an approach without vertical guidance. Whether you use the dive and drive technique or the stabilized descent path for a non-precision, completely up to you there. So here I can see I use vertical speed. I'm at a 600 foot per minute descent rate. Altitude target select is armed and it's going to level us at 1,300 unless I do something different. As we continue in, I prefer the stabilized descent path. But as we cross that next constraint, we finally get down to our minimums, call it 400 feet, still running a vertical speed of 600 feet per minute as we're coming down. I like to let the approach get me about a mile or so from the airfield. Upon reaching MDA, if you're using that stabilized descent, in my world, if I don't have what I need to land, I'm gonna go ahead and select toga and go missed. If we do the dive and drive, we're going to level out at MDA. We'll stay there until we hit the missed approach point, at which point, if we don't have what we need to land, we press toga back into the missed approach. But if you do see the airport, you get out of the clouds, you have the visibility you need, go ahead, disconnect. We can descend below MDA, and now we can land the aircraft. All right, So that's going to bring us up to the end. I know there's a lot of information I've put out there, a little bit different scenario than what we've had in the past. I hope we've learned a lot of good stuff there. Some of the primary references we're going to use here, obviously our G500 TXi, G3X Pilots Guides, G5, GI2 75 Pilots Guides. Very highly recommend running through the GFC 500 AFMS. That is going to be specific to your aircraft and what it's capable of doing. So very much highly recommend running through that. We didn't cover it at the beginning. If you go to garmin.com/GFC500, this is going to show on our website what aircraft are currently approved, what aircraft are currently going through their certification, as well as what is planned. If you don't see your aircraft on there, there is a link there where you can go and request that your aircraft be added to the AML. There's also an option if you're willing to loan us your aircraft to be used as part of that certification. Course here, feel free to visit us here at flygarmin.com/training. We do have several e-learning courses, G1000, GTN, TXi. We also offer instructor-led courses. We're still running our virtual courses as of right now. Hopefully we'll get back to the in-person courses soon. We can also create a custom class if you have a group of pilots, a flight school that want to get together that doesn't match up to one of our scheduled dates. We can give you a custom quote there as well. Of course, we've got our several YouTube webinars and videos off the Garmin Aviation YouTube site. I'd also give a plug to Sporties. Take a look at their YouTube site. The flight school I teach out of uses their video series for as part of our 141 course, and I know they have some incredibly phenomenal training products, so highly recommend taking a look at some of the Sporties products as well. So that is going to bring me up to the end. We'll leave. We still have some. I'll leave everything up, so if there's any last second questions. If not, if we don't get a question today answered, please email us here at aviationtraining.webinar@garmin.com, and I would be more than glad to answer any questions you have. But on behalf of the Garmin Aviation Training team, I want to thank Sporties for having us, and I'm going to go ahead and hand it back off to Eric. Eric, thanks.
Matt, thanks so much. A lot of great information. This is one I'm sure everyone that participated today will want to view over and over again. So just a reminder, the recording of today's presentation will be available in the Sporties webinar archives at sporties.com/webinars. There you can also take a look at upcoming presentations. It'll also be available on the Sporties YouTube channel. And I know it's off the screen now, but a couple of URL reminders from Matt, garmin.com/GFC500 for some additional information on the autopilot system, of course, and airplanes and approved airframes, and how you can make requests for your airplane, and also flygarmin.com/training for all those great training options from Garmin. I'll take another pause and just allow anyone from the Garmin training team who may want to jump in and respond potentially to any questions that have rolled in. I'll pause just a moment. Okay, I know the team did a great job behind the scenes getting a lot of those questions answered. So with that, we're just over our hour. I want to thank you so much again for joining us for the presentation on the GFC 500. Big thank you again to Matt Clark, as well as Paul and Gabe, who are working in the background from Garmin Aviation. Enjoyed having you. Great information. Thanks again for joining us. Fly safe, and check back again with Sporties for any future presentations, and safe flying for all. Have a great afternoon.